Okay. Hi, everyone. Thanks for joining the last session of today. So in this session, I'm going to talk about the Apache project called Pulsar, as well as its integration with Apache Flink. So first of all, let me introduce myself a little bit. My name is Neng Lu. So I'm currently a software engineer at Stream Native. I'm working on the functional or core processing part of the Apache Pulsar project, as well as working on the cloud infrastructure stuff. So before joining Stream Native, I'm working at Twitter in the real-time compute team, which we build the streaming solutions like Storm and Heron. And I'm generally interested in the event streaming technologies field. Okay, so first of all, what is Apache Pulsar? In a short sentence, it's a flexible PubSub messaging backed by durable log storage. So here is the brief history about Apache Pulsar. It was started in like 2012 in Yahoo, and after like several years development, it's like open source to Apache and recently been a top level project. And the community is growing like very fast. Like we have like over 250 contributors and 1.4K folks and 5.4K stars. And in the industry, like many people, many companies are utilizing it to serve their daily business needs, like Yahoo Japan, and Tencent in China. First of all, like in the first version or in the first major release of Pulsar in 1.x, it was like a pure like a messaging and storage system. Like has two major parts. One is messaging, and with multiple language client support, and the other part is stream storage, utilized by utilizing the low latency storage system like BookKeeper to achieve the goals. And in that age, like most of the Pulsar use cases are like unified events in center bus and building service, push notification, worker queue, log pipeline. So it's most of them are like a messaging related stuff. And later on, as the community is growing and people are adding more and more features, so we add a large chunk of it, which is the processing, as well as like multiple client support and multiple storage system support. So in this age, we have like a streaming first unified data processing philosophy in the whole like project. So in terms of data processing with Apache Pulsar, we actually have support like different mode. The first one is like interactive queries systems like Presto. And we also have support for stream and batch processing, as you know, like Flink, and we will talk about that later, and also Spark and Hive. And also it has its native APIs for some serverless functional processing called Pulsar functions. So for the data processing, we actually identified them as like into 4 different categories. The first one is interactive. Basically, the example is Presto. So you can use that to do time critical and median data size, and will be return on failure so that you can retry. And the other one is about a batch system. So basically you process a huge amount of data and run utilizing a large cluster to do some processing, as well as some providing the fault tolerance guarantees. So the third one is called streaming, so which I think it's the so of my original field. It's like you can do a long-running jobs, which is consuming data all the time, and respond all the things, all the events in a time-critical fashion. And also, like you have to considering the scalability as well as the fault tolerance issues. The last one is serverless, which is like new recent concept in the cloud age, which you have like simple language processing to do ETL jobs as well as integrate with the application needs, like with you will processing data with very high velocity. So the Flink, I think the Flink's view on computing is like streaming first, and the batch processing is a special case of streaming processing. This is kind of a recent like a passion of people's effort to trying to unify in the batching and streaming processing and abstract the batch processing as a special case. And I think many many projects like Apache Beam, like Apache Pulsar, and also Apache Flink, they're trying to like providing APIs to unify the expression of those jobs, of the user jobs, to in the proper fashion to handle that. And here, like Pulsar provided the view on data is like any data is like an infinite segment streams. So I think for these questions we can answer later. So let me finish first. Let me first finish the slides, finish the talk. So here, like Pulsar abstract the data as infinite segment streams. So it's a stream, but it's segmented. So with the segments, you can actually do some batch processing. And with streams, we're able to do the real-time streaming processing. So when Flink and Pulsar are combined together, and we can do a streaming first unified data processing to fulfill our daily business needs. So here's some reasons like why Pulsar fits well in Flink. First of all, it's a durability. So data is replicated and synced to disk, not only like kept for a short period of time, like 2 weeks or several days. You can also offload data to storage systems like Hadoop, so that you can keep them forever and you can process them whenever you need it. And it has a better, higher throughput and good performance. For a single partition, we see that we can support like 1.8 million messages per second. And also like different guarantees, which is a very hot topic in streaming engines recently, previously. It's like you need to provide at least once, at most once, and the effective ones semantics to ensure that your different applications can choose a proper semantics to achieve its goal. And it has the Pulsar has ordering guarantees with low latency and highly scalable and available. So when we here it's like the cloud native architecture of the Pulsar. I think the cloud native here, I think the major difference is like the major factor or major feature is like it's the computing and storage are separated. So in Pulsar, we actually have 2 layers. One is the serving layer. We have like stateless brokers to serve clients' need, like produce data or consume data. And then we have a durable storage layer, which is responsible for handling or saving all those data. And also whenever needed, they will be served. So with this like a separation of computing and storage, we can actually like scale out like either brokers or storage, either brokers or bookies separately to fulfill our needs without having to worry about like bindings or limitations and those kind of stuff. Also, it's a segment-centric storage. So we already know that Pulsar abstract data as a segmented data stream. So we have concept for each topic, we have partitions, and the partition is this is abstracted as a managed ledger in Pulsar. And in each managed ledger, we have multiple segments, which is which either each one is represented by a ledger in the storage system BookKeeper. So for each ledger, there's only a single writer, and it's append only. Like either like you successfully close that segment, or you have some you met some exceptions then failed. The ledger and the segment will all be closed and start a new one. And also it's replicated to multiple bookies to provide for torrents. I think. Yes. So here, like we actually have 3 different storage as the time axis shows. So this is the most recent time. We have brokers to have some data to serving to receiving from the producer and serving the consumers, which is maybe segment 4. Notice this segment might be like incomplete. It's still being appended new data. And for for the second most recent data, we put them into BookKeeper. These are kind of the segments for the last few hours or last few days. We save data there, and as time goes by, and some older data, even older data like 2 weeks ago data, and code data, then we will be these kind of are very cold data, and we will be like offloading them to different storage systems based on your choice, like Hadoop, like S3, Amazon Azure Blob Store, or Google Storage, so that like you can keep those data available whenever you need it, but also reduce the cost of storing them. Here, this is the logical view of a Pulsar, of a producer and consuming data from Pulsar. We have a topic abstraction, and within each topic, we will have like multiple partitions to scale out. And within each partitions, it's the segment we just discussed, based on the time, based on the recent times, we will have multiple segments to serve data, and the different segments will be stored in different storage systems. And here, so to like stream as a unified view on data, we will see like we have segment readers to pull data from different segments. This is while like the clients are still consuming the most recent data to for their messaging and part notification systems. So here it's the read is not sequential. You can actually like read in parallel from different segments to handle like batch processing and different stuff. Sorry. So we have actually two levels of reading APIs, just as the previous graph shows. We have PubSub streaming APIs, which you can read data from those brokers with the most recent data. And you can do like consume, seek, and receive operations. And we have, the Pulsar has different subscription models like failover, where you have standby clients to take over the traffic whenever the master client is done. And you have shared client, which everyone can share, each can share data. And you have Keyshare, the subscription model, which like based on the key of the data, client will be able to receive a certain key range data, and we can reprocessing data by rewinding the cursors. And also another one big part is about segment API or the batch API. You can read data from storage, either BookKeeper, which we have second recent data, and or tiered storage, which we have code data. And this is this supports like fine-grained parallelism. You can read them in parallel, and has some predict pushdown to further optimize the reading. So the unified data processing on Pulsar will be like you have bounded streams to process data, and if you like combine the previous old data with the recent one, most recent one, then it's considered as unbounded streams, and the streams is consistent of like different segments. So when Pulsar meets Flink, so when we have some support, and we developed many features in order to support like integrated Flink with Pulsar and support many like Flink features. So we have like connectors available, like the streaming source, streaming sync, and as well as table sync since Flink 1.6.0. And in Flink 1.9 integration, we have like a schema support in order for users to process their data more with the type. And also we have table API as first citizens. And also we added the exactly once source, since the exactly once semantics processing has been very hot topic by the stream processing field, as well as the at least once sync. So I think most of part is the next thing I want to discuss about is the Pulsar schemas. So the schemas, like we can like consensus data at server side, which the Pulsar itself has a built-in schema registry, and we're providing data schemas for each topic. And also like when the client can also like send and receive type the message directly with validation. And we support like schema evolution, like multiple versions and the compatibilities. So in order to like utilize a schema in Pulsar's producer, it will be as easy as you add the schema definition when creating the producer or creating your consumers. So the next thing is about the schema info. Currently, this is a JSON schema. So with the type information here, and these are the schema fields and their field properties. And the to utilize the schema, the procedure in a producer is like the application of the user is providing a schema to the producer, which we have been seeing in that code, like you provide a schema. And with this information, schema information provided to broker, the broker will check if it's registered or not. Then, if it's already, the schema is already restricted by previously, then it will be can return the schema version and use that schema directly. But if not, then we will check if it's compatible on based on the results. Like if it's no, then the schema will be rejected. And if it's yes, then we will store this version of the schema and then return its version for the producer to start to consume data. To produce data. And the whole process is pretty much the same for the consumer. Like you will do the same like loop and check and then start to consuming data. And for the compatibility strategies, we'll have like backward, forward, and for support. So with different versions, you can be able to read that with the newest schema. And for multiple versions, we have to like check the schema registry or the schema info provider to sure like we have the proper version for that schema and get the help the clients to handle that properly. So for Pulsar Flink, the schema is like if the topic don't have any schema, then the message payload will be filled directly in the value field. And if the topic with schema actually, so you will have the kept in a row and with metadata information. And I think here is some intuitive examples. So this is a primitive schema. Basically, you don't have schema information. So despite this shared metadata, you will have a value field with the payload available. And if you are using ever schema, so except the bottom like metadata, you will have ever schema information like fields I and all those stuff. Okay, so for Flink Pulsar source, so basically it's here like we provide like an API for you to directly creating a source with the proper properties set accordingly, and then you can do the processing directly and implement your Flink logic and do that processing logically. And here it's a table API support. So Pulsar properties. Yeah, it's TNMV. Yep. So that's the thing I want to show you guys. Here it's a topic partition discovery. So it's a little bit complicated, but here you can find matching topics and fetch schemas for each topic based on the schema registry we discussed previously. And we will build like a schema specific deserializer in order for readers to consume data properly. And each reader will be responsible for a single partition. And each source task has a partition discover task to check newly added partitions. So also we have exactly one source. This is the details are kind of a little bit complicated, but I just highlight some of the stuffs here. So you will be able to do message order on partition basis and do the seek and the read operations. And also it will be like able to checkpoint with message ID and the durable cursor to keep on checkpointed message alive and move cursor when checkpoint is completed, so that like the data will be make sure that it won't be like processed more than once. Okay, this here then after all the source and the processing logic, now we come to the sync. So basically you can just as easy as we can create a Flink Pulsar sync directly and add that to your streams to compose your Flink processing job. And also we have support for writing to table streamings. Okay. Here we have some although we have done some work on the Flink and the Pulsar integration, still there are many things to be done, and we have some kind of plans, like future directions, like Pulsar as a catalog, Pulsar as a state backend for Flink, and also scale out source parallelism with the Keyshare feature and sticky consumers. And also we want to support the end-to-end exactly once semantics with us with the Pulsar transaction fee support available in newer releases. Yeah, here is a diagram about the Keyshare subscription, which shows you why this is kind of important for supporting the exactly one semantics. Like here, like each consumer will only be responsible for a certain type or certain key range of data, so that like whenever it's filled and come back, you will be still responsible for these kind of messages, and ensure that there will be no duplicate processing for those data or missing data processing. Yeah, this is it's a key-based ordering. It provides a key-based ordering, and it can be the key can be either a message key or separate ordered key, and batch and have processes for messaging without keys, and it's a hashing-based routing. So here, I think it's a pretty quick. We now come to the conclusion, which is like Apache Pulsar itself is a cloud-native messaging stream system and has a multi-layer architecture. And it's like segment-centric storage, and with 2 levels of reading APIs. It provides a unified view of data, and also Flink provides a unified view of computing. So when we combine Flink and Pulsar together, it will becomes a streaming first and unified data processing with all the supporting features we have built, and also some of them are in progress. Yeah, I think it's just a few diagram to demonstrate the unified processing. Here is this is kind of the Pulsar community. So if you are interested, you can check out the website, you can follow the tweet and join in the Slack channel at the mail list, and you can check the code at here, the GitHub address. Yeah, okay. So I think that's pretty much I want to share with you guys. Kind of go through some of the big ideas in Pulsar and how the integration works for Pulsar and Flink. Yeah, yep. I think we can do some QA. So if you guys want. So I see one question asked previously. It's kind of talking about what's the advantages using Pulsar over Kafka. So to my limited understanding, I think a very a different feature for Pulsar. It's it's a separation of storage and computing. So you don't have to worry about provisioning. You can add the broker nodes or storage nodes independently based on your needs, and without worrying about something operation called rebalancing. So, and also based on some of my interaction or feedbacks from our users or customers, I think they found a better performance and a more stable cluster to maintain for them. So these are the things I heard from people. So if that answers your question or not. And also we are kind of, as we already showed in the previously, so we are kind of trying to integrating a lot of different data processing systems into Pulsar, so that we can make it kind of a centralized place for the data running through your infrastructure, and people can easily using different data processing tools to connect to them and get the result they want. Okay. Okay, the question is, can deep storage data be read from other systems other than Pulsar? So I think you're asking if you can use different APIs to consume, if you can use other systems API to consume data, right? I think that's possible because it's just a format how you store the data in system. As long, to my understanding, like as long as you have like a schema information, then you can utilize Presto to query Pulsar. And we are also trying to adding APIs into the into the bookie layer, so that like different systems can directly consume data from BookKeeper instead of Pulsar. So okay, so you're asking like, are there examples of production use case that you can share? So it's kind of interesting, like, so the earliest use case is from Yahoo. Even though the company is, I don't know, say that it's not doing well, but actually like it's kind of, Pulsar is used widely in Yahoo system to support Yahoo Financial and news kind of that. And some other recent use cases are actually from Chinese internet companies like Zhilin Zhaopin. Also, I heard also like Tencent. Also like Tencent, if you know, like Tencent is heavily like kind of trying to migrating the sales systems to Pulsar. So if you are a mobile game player, you know a game called 王者荣耀, they are actually, the billing system is built on top of Pulsar now. And within that, people are trying to widen its usage to different business groups. Can Presto query bookie? Is their official catalog? So I think, so the question is, can Presto query bookie, and is their official catalog? So the answer for your first question is yes, Presto can query bookie. So we have actually official support for the Pulsar SQL to help users to query data using Presto. Even though like currently the Presto, I think the currently supported version is Presto DB, not Presto SQL, but we can look into that. And that's another story. So it's an official catalog. So for this part, if you don't mind, I can check with my team members later and then share with you in the email or in offline fashion. So